Hi everyone, welcome to my channel. I hope you have already subscribed my channel. If not, please subscribe it and share the videos with your friends. As part of today's session, we are going to cover linear regression. Let us first understand what is regression. So I had covered it in my previous video, but let me give you a very small brief of this thing. So regression are the kind of machine learning problem where you try to predict a continuous variable. So suppose there are a lot of features. Suppose there are a lot of things based on which you can predict the price of something. So we had taken example of house pricing, right? So we have lot of features about a house, that how big, what is the size of that house, in which locality it is, and how many bedrooms are there in house, which is who is the builder who has constructed that house, and which city it is in, and a lot of other things, right? What are the amenities provided with that house? So based on all these features you can predict the price of a house, right? So price of a house is a continuous variable, so where the value can be between 1 to say $1 million. So these kind of predictions are called, these kind of problems are called regression problems. So in this, as part of this class, we are going to discuss linear regression algorithm. So the features, the variables which we are going to use to do prediction, the in case of our housing problem, housing price problem statement, size of the house, number of bedrooms in the house, number of bathrooms in the house, uh, kind of amenities, locality, all these things are explanatory variables. These are the variables which are going to explain our data, which are going to help us get predictions. We are going to donate these variables using X, and the variable which we are interested to predict in, so in our example that variable is uh, price of a house, so that variable is called dependent variable. Okay, so I hope this small thing is clear. Now let us move on to the actual problem in our hand. So we are going to keep it very simple, and we are going to start with one variable, linear regression. There can be multiple factors which are affecting the price of house or price of something, but we are going to take only one variable at a time to understand linear regression, and then we'll add multiple variable situation. Cool. So suppose we are going to predict price of pizza. Let us create a dummy data set. So x is our variable. Suppose we have pizzas of this size, centimeters. So we have pizzas of this size. Cool. And now we are listing down pizza cost, our output variable. You know, pizza of size 2 had cost of say $3, and size 3 had cost of say $4, and size 5 had cost of say $7, and size 7 had cost of say $10, and size 9 had cost of $11, and size 10 had say cost of $13. Let us first visualize this data. I had explained in my previous video that for visualization we are going to use matplotlib. Let us import matplotlib library. Cool. And now we need to run this magic function so that we can show our images within this notebook. Cool. Now let us print it. So plot x and y. Sorry. So we want to create a scatter plot. We want to create a scatter plot. Cool. This is our plot. Okay. So we can also give labels to our x-axis and y-axis. So let's call x-axis as pizza size and y-axis as uh, pizza cost. Awesome. So we have our graph ready. So you can see that as the size of pizza is increasing, the cost of pizza is also increasing. So they both have a linear relationship. So people who are not aware that what do we mean by linear relationship? So meaning is that you know there is a linear change in the value of the final variable if any of the parameter is changed. So here our parameter is pizza size. As the pizza size is increasing, the cost of pizza is also increasing. So that's a linear relationship. So let me draw it and show it also. Let's make it a bit bigger. Okay, so now I hope you're clear with what is linear relationship. If it is not clear, please post your comment in comment section. I'll answer that there also. So now, so here we have this thing. Suppose our, we make it a bit bigger. So suppose this is our data, and here we see a positive relationship. Here we have positive relationship between our x-axis and y-axis variable. Now there can be situation where there is this kind of data. So here, as the value of this thing is increasing, the value at the y-axis is also increasing. So we have a line like this. So here we have a positive relationship. There can be situation that value at x-axis is increasing and the value at is decreasing. This is called negative relationship. So I hope this is clear. So let us move on to our regression thing. Okay. So we had data like this for our pizza problem. So we have a linear relationship for our pizza problem. So we want to find out a line. Linear regression does this. It tries to find out a line which best represents this relationship, which best represents the data. So now there can be multiple lines, right? Which can be drawn here. There can be this line, there can be this line, and there can be this line. There can be multiple lines which can be drawn over this data set, which all are lines and all are showing linear relationship. Now how to find out that which line is best for our data set, which line is best fitting our data set? So this is the way. So we have a lot of data, and we find out a line. Now this line represents whatever our linear regression algorithm is going to predict. and this dots represents the actual value, actual cost of the pizza. So imagine this is 1, this is 2, this is 3, this is 4. So for a size of 3, our algorithm will say that this is the cost. Imagine there is a you know uh, point here also. Our algorithm will say that this is the cost, which can be, say, $4. Our algorithm can say that $4 is the cost, but in actual that cost can be 3. This is the actual data. This dot is the actual data, and all the points on the line represent the prediction. So that this difference in the actual cost and the predicted cost is our error. This difference is error. Pardon me for the handwriting here. It's very difficult to write it in this way. Uh, so so here for this variable, this point, this is the error. These are all errors. You can see here. For this point, this is the error. So so how do we find our best model? So best model in this case is the line which has minimum average error for all the points. That's what you can consider as the best model. In simple words, that's what is your linear regression algorithm. Uh, there are all the points scattered on your graph, and you want to find out a line which best represents your data. How will you find out that best representing line? Uh, the, so this line should be having the minimum error from all the points, minimum average error from all the points in your data set. I hope this is clear. Cool. So let us move ahead. Now we want to find out the line. Uh, Let us first understand what is the formula of a line. It is y. In your college or in your you know school days, you might have read this formula. Formula of line is this. So now let us understand that what does this formula represent. Suppose you have this line. So B, this is B. So doesn't matter, even if your x is 0, uh, y is going to have some value. So that value is going to be B. This is the offset, or this is the intercept in terminology of line. So this is the B. So where this line is intersecting y-axis, that's the intercept, and that is the value of B. X is your feature. In our case, in our pizza example, our feature was size of the pizza. So X is pizza size. X is pizza size. And what is W? W is slope of this line. W is slope of this line. So it tells that what is the gradient by which y will increase if x is increased. So that's the slope of the line. So that is W. So this is how we will get the uh, this is how we can. So linear regression is nothing but a formula. So predicting the value of getting the value of B and W from historical data. So we get lot of input data, like what is pizza size, and what is the relevant cost, we'll get thousands and thousands of that record. And by using those thousand historical data, we will we will estimate the value of b and w, and then this equation will give us the model. So a machine learning model is nothing but a formula, mathematical formula. In case if you are using linear regression, or if you are using sport vector machines, or if you are using logistic regression. So in case of decision tree or random forest, if you can think of it as a if else condition. So that's a easier way of understanding it. So here we had only one feature, which was pizza size. In real scenarios, take an example of our house price prediction scenario. There can be multiple variables, right? In case of pizza pricing also, there can be multiple variables. Your pizza cost can be dependent on number of toppings you have used, size of pizza, which restaurant you went to, and the amount of cheese you have got on that pizza, and whether your pizza is thin crust or thick crust. So there can be many features based on your based on which your pizza price can be decided. Let us list down some of those features. Suppose one of the feature is size, and let's call it x1. And next feature is toppings, number of toppings. Let's call it x2. And next feature is how much demand that pizza has. Let's call it x3. And amount of cheese. Let's call it x4. And there can be another thing like uh, you know uh, type of crust. So whether it is thin crust or thick crust pizza. So these can be features, right? So now our line our model is not actually a line. It has become multi-dimensional line, which is called hyperplane. So you know hyperplane. So you can. It is difficult to visualize it on my computer screen, because all we can do is create two-dimensional images. Think of it that you are in multi-dimensional space, and there is a hyperplane which is dividing that multi-dimensional space into two parts. So you know our formula for that hyperplane will look like w1 x1 plus w2 x2 plus w3 x3, and so on and so forth. Like if there are n planes, n features, we will call it wn xn. So this is going to be the uh, formula for our uh, you know hyperplane. So using historical data, we will estimate the value of b, w1, w2, w3, and up to wn. So that's what linear regression is all about. By seeing your historical data, you need to find out w1s, which we can call as weights, and the intercept value. So that's what linear regression does. I hope this was easier to understand. I have tried to keep my wording and terminology very simple. In our next video, which is of linear regression part 2, I'll add more complexity to it, and will make more complex model, and learn that how to uh, you know uh, how to uh, make complex linear regression models. Before that,